Those tears are running, I see them clearly. I hope you're waiting for me, saving up those rivers to make us see. Don't drift too far away, don't drift too far away from me, yeah. My ocean's running deep, my ocean's running way too deep to let you go. And I know that sometimes our passions are wasted on the wrong ones. And I know that we'll take a hurt before we wanna get one. And I know that my soul knew I loved you before I even knew you. Sometimes you gotta let it go, just hoping it comes back to you. This flame is never shaking. Smoke seriously, I'm blazing for you. Hear me singing over mountains, through the valleys, trying to make it to you. Don't drift too far away, don't drift too far away, my love. I hope you're on the way. Come meet me halfway, my love. I know that sometimes our passions are wasted on the wrong ones. And I know that we'll take
Hello, everybody, and welcome to class today. First, let me say that I am sorry about the delay in getting the stream notice out today. Having a little bit of technical difficulties, had to do a quick little reboot and a couple other things, but got it all worked out, so we were able to get up and running and streaming today. So we should have all of the course content in the course now, all the way through the end. The only thing that's not in there at this current time is the final exam, and that's not going to show up until final exam week, like the midterm. So if you want to look ahead and look at, what's coming up in the next module, and look ahead at like what the final project is going to be and all that kind of fun stuff, that all is available for you now. This is the first time that I've done this course, and I was updating some of the older material and all that kind of stuff. So, I kind of had to build it as we went along. So it's finally, everything's finally in place to where we can just kind of finish up the semester. And we are getting really close to the end of the semester. I think we only have like, 3 or so weeks left, maybe 3 or 4 more weeks or so. So we're getting really, really close. I want to just take a moment and kind of thank you all for sticking with me as we've gone through here. But today's stream, we're talking about the network and networking virtual machines. So we're going to look at how virtual machines connect to the physical network and how virtual machines connect to one another. We're also going to look at network configuration options for virtual machines, as well as basic virtual networking concepts. And we're going to look at some network tuning practices for virtual machines. So, as you all know, because this is a course that's, kind of in our networking program here, networking is kind of like the circulatory system in your body. It's the transport mechanism, for moving all the vital supplies, while your blood is what carries the nutrients to your organs, your computer networks traffic in information, data, that sort of thing. So that's And that data is crucial to the health and well-being of applications on a network, like in a data center environment. So when we're thinking about a virtual environment, networking is just as critical of a component of the architecture as it is in a physical environment. Ensuring that the data arrives in a timely fashion to all the virtual machines on the host is incredibly, incredibly important. And, as we've talked about in the last couple of weeks with storage and memory and all that kind of stuff, networking is also subject to bandwidth issues and constraints because of bottlenecking that can occur within the physical environment. So we also have to kind of consider, as we're setting up our networks, the sizing and implementation and management of those networks so that they can perform on our virtual, with our virtual environments in mind. As we've talked about over the last couple of weeks when we talk about, setting up a system, when we're setting up an ideal system for our virtualized environments, what should we set up with memory and what should we set up with storage and what should we set up with this or that? We should be setting up our networking environments in a similar way as well. We should be considering the impacts that networks have on the virtualized environment. So the big thing here is that connectivity is key. Virtual machines are isolated from physical resources without being connected via a network connection. So that connectivity that we get is absolutely important. Best practices then have been developed over time for physical network infrastructures that translate well into virtual environments. So we've figured it out, more or less. IT departments and data centers have been dealing with these technologies and issues for decades. And networking, though at times it can be quite complicated, it's got these well-defined models and practices for good performance. And we'll talk about a lot of them as we progress through our slides today. Consolidation, which we've talked about over the course of the last several weeks, places many VMs on a single host that must provide enough network bandwidth for all of the guests, for all of those virtual machines. So, that's something that you have to think about when you're setting up your network, right? In a traditional, completely physical environment, you have one machine, and one machine equals one IP, or it's one connection. But with your virtual environment, you can have many different VMs on a single host, and you have to have enough bandwidth to be able to accommodate for all those hosts. Because you could hypothetically have a whole bunch of hosts that are on that, or a whole bunch of guests that are on that host up and running and demanding network traffic at a single time. And it's the hypervisor, as we've talked about over the last several weeks. We've done this. We've talked about this thing where we've compared the hypervisor to like a conductor of an orchestra. It's the hypervisor, again in this case, that manages the network traffic from the virtual machines. That manages the network traffic from the virtual machines to the physical network. So we'll see some different examples of how we work with that as we progress onward today. So the guest operating system behaves as it does in a physical server. That's something that we've talked about too. The guest operating system doesn't really know any better. It's being tricked by the hypervisor. It thinks, the same way that it does on a physical server or a physical, host computer. It behaves the exact same way, connecting to a network interface card through a driver. But then it's that hypervisor that's doing that trick and emulating what appears to be the NIC to the guest operating system. That hypervisor then has its own driver that connects to the physical NIC. Now, what we have here in this graphic is a simplified view kind of the transaction that happens between the guest operating system, the hypervisor, and the physical server. So you can kind of see there, as we've talked about, as basically the slide describes. You have the guest operating system here on the virtual machine. It's making a request. It's making a request through the NIC driver here. And that request is going out to the hypervisor, to the network emulator. And that's passing it through a network driver there on the hypervisor and out to the physical NIC. And finally out to the network. When the response arrives, it then follows the reverse path to go back. So it would take all of these hops that it takes to get to the physical NIC and out to the network. It takes similar steps in reverse to go back to the guest. So it would go from the network to the physical NIC, to the NIC driver on the hypervisor, to the network emulator, to the network driver on the guest operating system, and then back to you or whomever is running that virtual machine. So that's what we're looking at when we're looking at virtual to physical networking on a virtual machine here. So, with virtual networks, hypervisors can manage virtual internal networks with virtual switches. Virtual machines connect to the virtual switches that are tied to physical NICs. Physical practices like network isolation can be extended into the virtual network. And we have this graphic here that shows the VMware model. So what we essentially have with multiple switches, as you see, we have two machines here. Let me grab a pen. In this machine, we have two NICs. One that's connecting to an external virtual switch. One that's connecting to an internal virtual switch. That internal virtual switch is networking this host, this guest host, with this guest host. So on this secondary NIC here, we're following it to this internal switch, and we're following it, and the same with this guest host here as well. So in that way, that connection there is networking these two machines here together. Then we have this external switch and this external switch that are connecting these two guests, the first one here and the last one here, to physical NICs and to the network. And notice that they're connecting them to two different physical NICs onto two different networks. And that's all going to be dependent on, what your physical server has the capabilities of doing. If you have multiple external switches, they're going to be able to accommodate, or if you have multiple NICs, you're going to need multiple external virtual switches to accommodate that sort of thing. So that's what we're dealing with here in this example. So this is what we were this is the same sort of thing in dealing with multiple virtual switches. However, in this case, we are using the Zen model, which is also similar to the Microsoft Hyper-V model. Remember that the previous screen was looking at the VMware model. So since we're spending most of our time on the VMware stuff, we won't linger on this too much. But you can kind of see how this is different. It highlights the fact that all of the traffic goes from the child partitions through DOM 0. So everything from DOM U, let me get my pen back here, from this DOM U and from this DOM U, all of it goes through DOM 0. So all of these virtual NICs, this virtual NIC here connects to this internal virtual switch, which connects these two child virtual machines together. So they're networked together. And then this virtual NIC is connected to this external virtual switch, which is connected to this virtual NIC, and then through the hypervisor to the physical NIC. So you can see a lot of similarities here, but it's very, very different. In terms of how the hypervisor manages all the connections and everything that's going on there. So in that regard, you can kind of see how, and I can kind of pull back the other screen, you can kind of see how differently the VMware model is, which is this example, versus the Zen and Microsoft Hyper-V models in comparison to how they handle network connectivities. So let's talk about storage traffic on the network for a little bit. So with network attached storage, or a NAS, we're using virtual switches and physical NICs. Just like with any other device that we virtualized on our network. Storage I/O, which is our storage input and output, we want to isolate that from user traffic with separate virtual and physical network paths. So let's talk about that a little more. So in our example here, we have a virtual switch that is dedicated to a storage input-output, which is, in this instance, denoted by this fella here. So each of the virtual machines has a virtual NIC that is dedicated to storage traffic. So we got this virtual NIC, this virtual NIC, and this virtual NIC all goes to our storage virtual switch, right? The virtual NICs connect to the storage virtual switch, and the three switch types, the internal, external, and storage switches are identical in their construction and operation and have only been given different names here for the sake of differentiating them. So all of our virtual switches here, they're the same. We've just named them something different just to kind of show that the storage is going on different paths and that we're separating and isolating that storage I/O from the normal user traffic to the network. And so we have that virtual NIC that's going on that path that follows the storage switch to that physical NIC that's going to our NAS here. So whether the virtual NICs are handling user data for the network or data from the storage devices, from inside the virtual machine, everything still looks like it would from inside a physical machine. Remember again that it's the hypervisor that's handling all the other stuff. The hypervisor, again, is that conductor. That's, I'm waving my hand in the air. You can't see it. I don't have a webcam on me. I don't know why I'm doing it. I'm waving my hand in the air like I'm conducting an orchestra. The hypervisor is that conductor that is managing all of the connections. So as far as, as we've said multiple times now, as it conducts and make sure it's doing its job there, it's tricking those guest operating systems. They don't know the difference. They think they're physical machines. So here we have a bridged network connection. Let me turn over in my notes to get here. Yes. All right. So each virtual machine has a unique IP address that is recognized and reachable from outside the host. And we've seen that now as we've done examples. Like you can, if you put an appliance on a virtual machine, you can access that appliance from your, physical machine on your Type 2, with your Type 2 hypervisor virtual machines that we've done as examples for class and such. And then the hypervisor manages that traffic through the virtual switches. A bridged network allows each virtual machine to have that unique IP address that is recognized and reachable from the outside host. The virtual adapter behaves as a virtual switch and just routes the outbound traffic to its associated physical NIC and then out to the physical network. So when inbound traffic appears through the NIC, that virtual adapter acts as a switch and directs the traffic to the correct virtual machine. And so that's really what we're seeing in our graphic here. Our graphic is showing us a simple illustration of two virtual machines connected to a bridged network configuration. So they have unique IP addresses that allow them to be seen by other systems on the local network. It's almost like they're subnetted, in a way. I'm not sure if that's a great example, but maybe it helps you to kind of wrap your head around it a little bit. Who knows? But they're added to the subnet. We can also do NAT and do network address translation. So a NAT network, in a way, is blending between the host only that we've looked at in the past, which only lets you kind of communicate with the host, and the bridged networks that we looked at on the last slide. Virtual machines connected to the NAT have IP addresses that are isolated from the physical network, but they have access to the network outside of their host. So in our graphic here, what we're seeing is a simple example of a virtual machine with a NAT connection. So each virtual machine has an IP address that is recognizable by the other virtual machine on the internal network, but that address is not visible from outside of the host. So while you're on your host, you can address either one of these machines and get onto it and work with it and do whatever you need to do with it. But once you get to another device that's off somewhere, some third party or third device that's not hosting these VMs, you cannot access these virtual machines. When the network data arrives, the physical NIC passes it to the hypervisor to retranslate the address and reroute the information to the correct virtual machine. Because that's really what we're seeing there, is a translation of the information that's going to it and a retranslation back. So we can talk a little bit about tuning practices here. So best practices that have been developed over time for physical network infrastructures translate well to virtual environments. So that's a good way to start off. As you think about how you've tuned your physical networks in your other networking classes and how you have improved physical networks and made them better and done work with them, those best practices that you've done with them also work on a virtualized environment. Network input-output control can guarantee adequate network bandwidth to individual VMs, groups of VMs, or classes of traffic during high usage and contention. So we can just kind of, when you're thinking network I/O control, which is currently only available on VMware ESX, essentially what you're thinking of there is essentially just throttling, if we're going to kind of oversimplify it. You want to make sure that you have good network bandwidth, so you kind of want to control the flow by shaping those packets and kind of, doing what you can do with it there. And we have tools available from virtualization vendors and networking vendors that can monitor network traffic. So, just like with the first bullet point there, with best practices that have been developed for physical network infrastructures, when you think about the things that you have done in your networking classes that have pushed forward and helped you monitor network traffic and all of that kind of stuff, those sorts of things can still help you in your virtual environments. And we also have virtualized tools that, come from VMware and come from other companies that can do similar things, but, the things that you're used to will work as well. So there's no need to try to reinvent the wheel when you have things that you're used to using on networking environments to test networks and to optimize things and tune the networks and try to, work with different stuff on the networks. So as we summarize here, virtual machines rely on networking as their only connectivity to the physical world. Remember, networks are the plumbing in the virtual infrastructure, providing applications with data. So many of the traditional network best practices are applicable in the virtual environment. Virtual networks can be created inside a virtualization host for network and guest isolation. We looked at a bunch of those different ways that we can do virtualized networks. We looked at bridged and we looked at NAT and all that kind of stuff. Bandwidth and throughput are crucial factors in providing network resources to virtual machines. Storage and user traffic may travel across the same pathways. So, if we want to, we might want to separate that storage and user throughput traffic if we want to make sure that we keep that bandwidth nice and open. And then best practices that were developed on physical networks can also apply to virtual networks. That's one of the big takeaways that we can take away from this entire thing today, is that the things that we have learned about that we can do on physical networks, we can also do them on virtual networks. So the things that you have done in all of your networking classes, you can still do them on virtual networks. There really is not much of a difference at all. So that puts us to roughly 30 minutes, which is where I like to keep these live streams, which is great. We've been doing a good job at keeping these there. I'm going to go ahead and start the music back up. If anybody in the chat has any questions, I'll hang out in the chat for just a moment and answer what I can. But thank you for coming to class this week. And we will see you next time.